we're into physical security. And physical security, I got to tell you guys, easy as pie. All you guys have been doing physical security for a long time. All the concepts, easy, fun, no problem on the exam. A couple of terminology items, that's about it. But conceptually, really nothing to see here. Move along, move along. Okay. So physical security can come in several different flavors. It can be internal. I mean, you've got, and internal basically means, users, your people that are actually inside the facility. It can be external, obviously, and it's people, it's physical factors, environmental factors, all of those things. Anything but pretty much on the other side of your firewall is considered external. Natural, fires, floods, earthquakes, those kind of things. Man-made errors. There's, obviously it's errors caused by people. And then you have situations where you've got some kind of hardware issue maybe, or some kind of software problem. The fact that hardware and software, that all kind of is generated by people, you can kind of think of those things as kind of man-made, but in some of the security environments, they tend to lump those into a different category. Security Plus is pretty straightforward. They just kind of basically make it man-made or naturally occurring kind of a thing. But again, there's multiple sources, multiple locations where your threat can originate. Hardware attacks, that's an obvious issue with physical security. If you have the ability to access the hardware, that can't end well. If you can access it for the purpose of compromising it, installing a key logging dongle between your keyboard and your computer, that kind of stupid stuff, stealing the hard drive, stealing the entire server, reprogramming the router, destroying the router, cutting the cables. So hardware attacks can, again, if you have access to the hardware, you potentially have access to the data. And if you have access to the hardware, you definitely have the ability to damage the hardware. So, so both of your broad attack types are certainly available through hardware attacks. And there's a little blurb in the book talking about key logging, which essentially is a way to log keystrokes for the purpose of primarily stealing passwords. And these key loggers in many cases are paired up with dialer programs that actually connect to a remote location to download the keylog files. But again, it's generally these key loggers require physical access to the machine the user is on. So you may not have that level of access, or potentially you might. Environmental stuff, the things that are kind of not man-made issues. Things like fires. Fires are bad. You've got issues with fire suppression systems, fire preventative, fire resistant to construction techniques. So again, we'll get into a little bit more action on fires later. Obviously, hurricanes and tornadoes and monsoons and tsunamis and those kind of things will potentially affect you, depending on where you're physically located. If you're right on the beach or something, obviously there's different physical threats than if you were located up in the mountains. But every location has its own particular set of problems. Floods, that you generally need to be in a flood-prone area to suffer from that. And again, this gets to our sort of risk process, our risk analysis process a little bit. You might be in a coastal area, and there may not be a whole lot you can do about flooding. What you can do is you can purchase flood insurance, and any any damage to the facility can be covered by this flood insurance, and you simply factor that into your cost profile, and we'll talk about that later too. Temperature and humidity issues. I mean, again, computers and computer systems tend to like to operate in pretty much the same environment where we like to operate, the same temperature ranges, same humidity ranges. I mean, yeah, I read about that. Clay was just saying there's a demo of some USB device that if you stick it in a machine, it'll pretty much wipe out that machine just by the act of sticking in there and getting it read. I have read something about that. That's an interesting exploit as well. So I guess the policy of not sticking any non-certified USB devices into your State Department computers is probably not a bad idea. Back to temperature and humidity. Extremes in temperature can obviously damage equipment and affect data storage. Humidity issues, you've got low humidity, which leads to electrostatic discharge problems, static electricity, which can lead to damaging those those doggone integrated circuits, those chips. Man, there's a lot of information packed into a pretty small space. So even a little static discharge onto one of those chips can cause serious unseen damage to that chip. So again, electrostatic discharge procedure is very important. So maintaining a humidity within somewhere in the 40 to 60% humidity range is generally good. High humidity leads to condensation and corrosion issues and those kind of things. So you really do need to maintain both of those things. And so your overall HVAC, right, heating, ventilation, air conditioning environment needs to be monitored and controlled and managed. All right. There's a little activity associated with identifying physical threats and vulnerabilities. Pretty straightforward. And that's the end of chapter, what is this, chapter 2? That's the end of chapter 2. So I'm going to go ahead and segue into chapter 3, which is managing data, application, and something else, and host security. So give me a minute to upload the new and improved PowerPoint presentation. Managing data, application, host security, right? So we'll look at managing the various things you can see on the slide there. No sense belaboring that point. All right. And I got to move to this. All right. Here's a concept, layered security. Don't be one of those guys that thinks all your problems will be solved by spending a lot of money on some sexy firewall. That's great, but a lot of things don't go through your firewall. Things that originate on the inside, that's not going to help you at all. So a multi-pronged sort of attack here is going to provide the most benefit. So the general concept is layered security. Encrypt your data. Harden your, configure your routers so where they're properly secured and do what they need to do. Configure your firewalls properly. Use antivirus software. So, don't put all your eggs in one basket. So, and there's, again, a variety of threats, a variety of different ways to counter those threats. So this kind of layered security approach, basically applying security at multiple layers, and that applies to multiple layers in the protocol suite. And you've got, physical security, and you've got wireless security, you've got network security, you've got a variety of different security elements to supply. So another related concept to that is defense in depth. Takes that layered approach, doesn't focus on just the tools necessary to do these things. It focuses on everything, kind of a holistic approach, training and perimeter defense, physical, boundaries and so on. So defense in depth really goes from the fence line to the minefield, through the interior fence line, to the outer shell of the building, to the, So again, you've got multiple layers, multiple perimeters that would need to be breached in order to get to the next zone. and providing protection all along the way. Note, defense in depth comes from the military strategy of delaying an enemy's advance rather than meeting them head on. So I'm not going to go into military tactics here, but that's where that comes from. So, I mean, basically, at the center of your target would be the data, and then the kind of next line of defense would be the application protection, the protections built in at the application level. The next level outside the application would be your host. That would include your operating system and the physical protections afforded your actual host machine, any like your host-based firewall, like your Windows firewall potentially. Then you've got the network itself, where you've got firewall protection, and router protection, and intrusion detection sensors, those kind of things. Then, of course, the perimeter network. You've got what's known as a DMZ, which we'll talk about, but basically a protected network space between the internet and your internal network. And then you got your physical stuff, right? Your actual fire suppression systems and buildings and doors and windows and locks and fencing and those kind of things, surveillance cameras. And then the outer ring of this whole thing would be your actual written policies that the organization is effectively governed by, followed by your awareness programs and training and all of that jazz. So again, you got to penetrate from the outside in to get to the data. So the point is to delay the bad guy getting to the data as best you can while you do whatever it is you need to do. And there's always the ability to unplug machines from the network and physically lock down the space. And so again, just having multiple layers that need to be penetrated is sort of the operative security concept here. What is data security? Let's look. Controls, measures implemented to secure an organization's data. So the data is the thing, and there's things you do to protect your data. That kind of makes sense. And the data lives on data storage systems, servers and such, devices that access them, your workstations and infrastructure items, routers, switches, those kind of things. And all that stuff should be pretty clearly laid out in your organizational policies so that those policy items can be implemented using tools like group policy and so on. So again, data security is all about the data, but the data lives on these other components, these other devices. Data security vulnerabilities. The cloud is kind of a big deal, and we're, the State Department is kind of hesitant to kind of relinquish control and kind of move to the cloud. But we're doing some cloud. This is cloud-based. This is internet-based training. So we're embracing certain cloud-related things, and of course, the whole concept of a cloud is putting your data on the other side of your firewall, trusting your data to Google to manage or some other, Amazon or some other provider. Now, of course, there's plenty of cloud providers that provide services to the government, and the government folks are the ones that are in there managing it, not the Google folks and so on. So it's not like we're just giving up control of data to some random third party, knuckleheads. So it's and it's evolving. The processes are becoming more well defined, and the procedures are becoming more clear. Lack of restricted access to data systems. Well, if the data is now residing other than some secure internal location, that's a potential issue. You've got, and of course, users kind of need to be on board. They need to understand what's going on, what they can and can't do, what their responsibilities are, having to do with data security, and that's an ongoing process that's covered by policies. Storage methods. All right, there's some terminology for you. DAS, directly attached storage, or direct attached storage. traditional network servers, right? Those are your directly attached storage. Your NAS devices, your network attached storage, that's sort of the replacement, if you will, for the traditional file server. And these NAS appliances, typically they're running a purpose-built operating system. Usually it's a Linux-based operating system that does, that performs its function very, very well at high speed, and high speed sort of disk resources within. So it's a natural sort of upgrade to the old school server concept. Then your SAN, your storage area network, which is kind of a dedicated, it's kind of conceptually like a LAN, but it uses different hardware, different protocols. It's for high speed retrieval of data, and more organizations are turning to SANs. The dedicated networks provide block level storage of data. So again, that's we're concerned mostly with high speed data retrieval, not concerned necessarily with thinking of things in traditional file related context, but the actual individual data blocks and the best ways to move those things around. And of course, then there's the cloud, which is basically just a data center on the other side of your firewall. That's kind of what that is. So we're kind of migrating slowly but surely from the direct attached storage model into some of these other models. And we've got a couple of pretty much high-powered data center SAN sort of operations at the State Department as well. Your ESOCs, and then of course in private industry you've got the same thing. So you want to be just generally aware of what these data storage methods are. Encryption methods. Okay, data encryption. Well, first of all, we'll start at excuse me, full disk encryption. There are technologies that support that. There's a Microsoft technology called BitLocker, which we haven't fully implemented at State yet, but my understanding is it's on the way. We're going to be doing it. But full disk encryption, the benefit there is if someone steals your physical disk, they can't access the files on it. Everything's encrypted in such a way that they'll be unable to decrypt that. Database encryption, basically that makes perfect sense. And in fact, the database itself, maybe not the whole database is encrypted, but certain critical elements, passwords and user account information, maybe that stuff is fully encrypted. But again, that's not necessarily the whole disk, but it's what's on a potential disk. You've got your file encryption, and basically Microsoft has had something called EFS, encrypting file system, available for many years, which enables users to protect their files using public key cryptography, self-generated certificates and so on. And there's other forms of file encryption as well. Removable media has always been a problem, but now there are encryption methods that can be used to ensure that removable media is also encrypted and not available without the appropriate keys. Mobile devices, of course, in organizations that allow certain mobile devices, they're depending on the level of security, that mobile device may need to support full device encryption, the ability to wipe it remotely, the ability to find it and retrieve it remotely. Email encryption, we're familiar with that. There's a couple of email encryption programs. A lot of folks use SMIME, Secure Multipurpose Internet Mail Extensions. And there are other email encryption technologies. And voice encryption. Now, the thing about voice is we're rapidly converging our voice traffic onto our data networks, voice over IP. So the deal is, unless you encrypt your voice, anybody that's sniffing your network traffic will be able to pull off those voice packets, reconstruct the entire voice conversation, and that can't be good. So now many of your voice codecs support encryption as well. So again, there's a variety of things, data, communications, and so on that need to be encrypted, and there's multiple methods to get that done. Then we get into our hardware-based encryption devices, our HSM, our hardware security modules. And these hardware security modules either supplement security from a hardware perspective or provide all of the security, enforces encryption, decryption, and so on. So, you've got, what I'm talking about. For example, here in the State Department, we've got, we're limited to what sort of USB devices or removable devices we can use. And if you need to use a USB drive on a government machine, you're pretty much restricted to the iron key. That's so long, son. Call me tomorrow, and we'll do this thing. Yeah, my kids just crawled out of the basement. They play some weird internet game down there until all the wee hours of the morning, so that's what's going on there. So please forgive the interruption. All right. Encryption, access control using HSM. So in other words, you can use these hardware devices to require the hardware device to be in play in order to encrypt/decrypt that data. You can use that to allow/deny access to internal programs or external programs. Benefits: prevents unauthorized storage mapping. In other words, you can prevent someone from creating a link to a storage location based on the requirement to have that hardware module there. Same thing with copying data. The hardware module is kind of a standalone deal, so it's not going to be directly affected or unduly influenced by operating system considerations, because that's the nice thing about hardware, is it's got its own little deal going on there. And again, by using hardware protection, you're pretty much guaranteeing that all of those devices are fall under its protection. A particular device that you may be familiar with, your current crop of motherboards have what's called a TPM chip, a Trusted Platform Module chip, which is an encryption chip, which is pretty much unique to each installation, and that's where the keys are generated and stored for things like full disk encryption, so that if you remove an encrypted disk from a TPM configured machine, you're going to be unable to decrypt that disk anywhere else. So it's really pretty powerful technology. Hard to fake. So you got a couple of hardware-based devices, terminology things you need to be aware of. TPM, that Trusted Platform Module, and write this down somewhere in your book. They kind of like version 1.2, TPM v 1.2. Just kind of make a note of that. That's for some reason seems to pop up on the test. Again, it's that TPM chip is a crypto chip. Again, it generates keys, it stores keys, it's used for a variety of encryption/authentication purposes, and haven't fully implemented all the benefits that TPM provides in our organization yet, but at some point we will. The generalized term HSM, Hardware Security Module, and again, these HSMs can be removable or not or whatever and provide a variety of hardware-related functions. There's USB devices that support encryption. Specifically, I mentioned the iron key because for us, that's like the only USB device that we're allowed to use. And me being a lowly contractor, I don't get one. Poor me. And of course, hard drive encryption. And again, encryption is good, and the hardware encryption can be managed/controlled by these hardware devices. Like I mentioned, the TPM connection earlier. BitLocker can be configured to use that TPM chip to provide that part of that key. And if you remove that device from that machine, you're not going to be able to decrypt that hardware, making it pretty useful. Okay, so again, be aware of those terms. You're going to see those again. Data states mention this. Data is either at rest, meaning it's stored on a hard drive somewhere, and there's a variety of encryption methods that they mention in the book for disk. I've already mentioned BitLocker, but the different OSs have their own versions. There's database encryption available from the various database vendors. Again, the good news about the exam. The exam doesn't really get you all wrapped up in third-party names of third-party devices and applications and so on. So it's interesting for kind of a real-life scenario, but doesn't have a whole lot of test relevance. So there's that. So we're thinking disk encryption primarily is what's going on here, or removable device encryption. Once data is in transit, once data is moving on a network, well, now then we've got a different set of parameters to think about. You've got HTTPS, right, which uses a secure sockets layer. It's more and more using transport layer security, TLS. You got your wireless protocols like WPA2. You've got VPNs, which provide encryption over a public network, which is kind of the claim to fame of those guys. IP security, or IPsec, that's sort of built into IP, which allows two endpoints to negotiate a variety of security parameters and then have that data securely transmitted across a public network. Secure Shell, SSH, is a certificate-based public key infrastructure-based suite, if you will, of security processes that provides a replacement or a supplement for older non-secure protocols like Telnet or FTP. Basically, SSH provides secure replacements for both of those guys. So again, as data is moving across the network, we need to protect it in a network environment. And finally, data in use. You're actually accessing the data, you're using the data, is being processed by application programs and so on. So again, you've got normal computer operations. You've got data stored in RAM. Some data winds up being stored in what's known as the page file, or basically virtual storage, which requires protection, or someone could potentially get at some sensitive information that's temporarily stored in a swap file. So again, most of that sort of stuff is managed / controlled by the operating system. So the process of hardening, or kind of reducing the attack surface, minimizing vulnerabilities at the operating system level, is very important. They mentioned a web proxy, the concept of a web proxy, which basically a proxy server is provides a single point of entrance and exit from the internet, and it provides a variety of functions, firewall type functions and filtering functions and logging functions, and also the benefit there is any traffic originating on the inside is not the same traffic that actually goes to the outside. A proxy server regenerates the entire packet with itself as the source, so there's no clue, there's no indication on the other side of the proxy, the internet side, of where that data actually originated. So it also provides those security benefits. So that's again, so the data exists in these kind of sort of three different sort of states of matter, and there are different protection technologies associated with each one, and you generally need to be familiar with those as well. Permissions and access control lists. Okay, we don't necessarily need to limit ourselves to just thinking of Microsoft, but it's a pretty good environment to talk about. Permissions associated with files, folders, and printers. Who can read, write, access at what level. And those, you go to the resource, and if you have appropriate permissions to modify those permissions, and basically there's your administrators that do that, provide the appropriate level of permissions as necessary. And there's a whole sort of infrastructure based on systems administration and the proper way to administer permissions and so on, based on users and groups, and we're not really going to get deeply into that. Now your ACL, your access control list, and remember that's part of a discretionary access control list model. The ACL determines who can access what and at what level. ACLs allow one entity to have read access to a resource and allow another entity to have full control access to the same resource. And also they mention MAC address filters on wireless routers and wireless access points. Basically, the wireless router is basically a wireless access point co-located in the same box as a router, so really it's just access point. And a MAC address filter is a filtering technique that allows you to specify by MAC address who is or is not allowed to even use this access point. That way you can basically restrict access to a particular wireless network to pre-approved hardware devices. That is not the be-all, end-all to security. The problem with that is your real hacker type hackers, they can potentially get around that. And so the point is, you've got your network traffic is kind of banging around wirelessly in the air, and our bad guy is sitting out in the parking lot capturing traffic and looking at packets. He may not be able to read anything because of the encryption involved, but this guy's going to see things like MAC addresses and go, hey, this MAC address is getting a lot of airplay. I think I'll steal it, because it's very easy to spoof a MAC address. So basically, MAC address filtering is going to keep 99% of the knuckleheads out, but it's that 1% that you need to worry about. So it's those determined hackers that are smarter than the average bear that know what they're doing. That MAC address filtering is not a 100% foolproof way to keep bad guys off your network. It's a good way to keep knuckleheads off your network, and you should use it, but you should also be aware that that's not the only security method you need to put into effect. All right, so MAC address filtering, good, but with caveats. Here's a new term, the term big data. Okay, nowadays companies are dealing in data that transcends their local database. We're looking for trends in huge data repositories and data collections and so on. So there are special techniques, special bits of software and so on that are designed to process and analyze this so-called big data. And big data, by the way, is a nice buzzword to put on your resume and going forward, because if you kind of do a little bit of searching, you'll see that big data, knowledge of big data is kind of starting to be highly sought after in the public sector for sure, and in the private sector will soon follow, obviously. So the deal is, if I'm dealing with big data, there's a lot of very potentially sensitive information in there. So you have to be very careful as to how much of that information and to what degree you expose it. I mean, exposing like summarized information for making these sorts of analyses might be the thing to do by hiding the details of individual personally identifiable information. You're not likely to get in trouble where you're just kind of aggregating it all as a whole and restricting visibility to just this aggregate data and not allowing users to drill down to like the individual component of that data, which is personally identifiable and protected and so on. So again, that's a whole area that's being developed even as we speak. Designing big data to work with trusted parties and integrate non-repudiation. The fact that you can't deny the fact that you viewed this data or you provided access to this data, that kind of thing. So again, big data is kind of the new thing in sort of, I don't even want to call it a database, new thing in handling data. So you might see some reference to, in all likelihood, you will see some reference to big data on the exam because it's in the book and it's new, so that generally indicates that it's going to make an appearance on the exam. Data, this goes, remember we talked about your security policy. Well, your security policy covers all of your individual policies kind of taken together. So the policies covering data specifically, that's part of your security policy. But let's talk about data policies. You've got your acceptable use policies, which basically specify what you can and cannot do with company equipment, and that would involve how you view and manage data as well. It's important enough, as the second bullet states, it's probably deserving of its own policy, because you can kind of drill down to the level of personal data and protection and safety and of that stuff. So again, data has a life of its own. At some point, that data needs to be eliminated, and simple deletion probably won't completely eliminate said data. Wiping potentially is something that may need to be performed. And again, just normal erasing doesn't really do anything other than modify a couple of characters in the header of a file and remove the entry from the file table, basically freeing up the space that data takes up on the hard drive. But that means the data is still there until it gets overwritten, so somebody with appropriate tools can go in there and retrieve this sort of residual information and maybe piece it together and make sense out of it. So wiping is a little more sophisticated than just erasing. It involves generally multiple overwrites and wiping out the data, overriding it with multiple overwrites of different characters. Generally, the magic number is like 7 times. You overwrite this data 7 times, which isn't even a complete guarantee that it's gone forever. There have been studies, there's information showing that some residual magnetic data may still exist as many as 21 generations deep. So you can erase, but some ghost of the older data may still be retrievable. So that's interesting. That's scary. Disposal. Some data can be disposed. Some data needs to be disposed in using certain techniques. Other data can be simply thrown away, or run through the shredder, or sent to the burn barrel, or launched into the sun. Whatever. So there's disposal policies for data at different levels, different categories. There's retention policies. The last thing you want to do is delete some emails, not knowing that they're a big deal, only to find out that you're in violation of several federal regulations by destroying data. It's like, what? No, I didn't. So again, you've got to be aware of the retention requirements for different types of data, and generally email is considered data like any other data these days. Storage, what sort of devices, what sort of conditions are these devices, or is this data stored in? There are kind of optimal locations. Clay, stop that. Yes, you should all immediately have your own private email server installed in your house. I got that from very high authority within this organization, so that apparently is the right thing to do. So don't answer that way on the test, though. I fully suspect you'll get that answer wrong. Okay, and storage guidelines. Notice, if you will, in the book, right at this point, it says, hey, all the guidelines for this lesson are available as checklists from that checklist tile within, when you go up to the logical operations site. The checklists, first of all, let me kind of divest myself here. Checklists are good. I'm a Navy pilot, and from day one, from my first flight in a naval aircraft to every subsequent flight, before you do anything else, you run through the checklist each and every single time. Not that I don't have those procedures. It's been 20 years. I still have the procedures memorized for my aircraft that I flew. But that's not the point. The point is, you don't want to rely on memory because you've got it in a checklist and you're required to go through it item by item. Things happen. You might forget something or you might be distracted, but you can always go back to the checklist. And again, the thing is, there's procedures in our job. We've got things to handle. There's a lot of steps. It's pretty complex stuff. And you don't want to, kind of rely on memory to get something done, because if something that wasn't even your fault happens and causes a problem, it can be traced back to you. And the fact that you didn't go through the approved procedures and go through the checklist, and you missed a step, which might not have even been a material step, it can still show a pattern of negligence on your part, and we don't want that. We want to protect ourselves, give our data the best chance of making it to retirement age and living life in a archive safe somewhere on a tropical island and drinking boat drinks and stuff. So so use you develop checklists, use checklists. Checklists in many cases are provided for you. You will find them in places like NIST documents, SANS.org. You'll find some of that stuff there. I mean, you don't have to reinvent the wheel here. A lot of this stuff, people have been in this position before and have come up with solutions that you are more than welcome to leverage. Please do. It shows that you're a smart company man and you're going to go far in this organization, or any organization for that matter. Okay, so checklist good. Guidelines for managing data security. Again, layered security, good. Chances are you're not the facilities guy as well as the database administrator as well as whatever. There's multiple jobs that they all have their specific areas of expertise, but just because you don't manage the facility yourself doesn't mean you don't bring the facilities guy into the meeting, and the database guy into the meeting, and the server guy into the meeting, and the designers, the developers into the meetings, and kind of work out the security plan. Design that layered security so where one guy's not stepping on another guy's toes, and work all that stuff out. Determine your data storage requirements and the specific unique controls for each of those. You've got, again, in the federal space, we use what's called the Risk Management Framework, RMF, which is governed by a variety of NIST documents. If you want to pursue this further, you could take my FIRA class, my Federal Information Risk Assessment class, and there's one on the 20th of April. Or B, if you want to get an idea of what the hell is Mark talking about, go to NIST.gov. Go to the website and search on SP, special publication, 800-37. Start with 800-37. It's very short, 30 or so pages, which describes the risk management framework and all the steps and parts and pieces. There's another 100 documents that covers all the details. But go read 800-37. It'll be worth your time, and it's all about how we as an organization manage risk using the risk management framework as our guideline for building our procedures, and that risk management framework also defines our various controls. Because it says right here, consider implementing controls to protect data in transit. You want to see the control catalog? Go to the special pub 800-53. 800-53 is your controls catalog. Appendix F of that thing is 1 million pages long, and it's got every possible control in existence in there, and it's all about protecting data. So go read the 800-37. It's short, and that's an easy, fun thing to do. To just get just wrap your head around this concept of this risk management framework. And then if you're ready to go look in just a little more detail at what the future holds, go take a look at 800-53, which is the controls catalog, and you'll go, whoa, this is pretty intense. There's a lot of stuff going on there. Oh no, you're gonna. I'm serious. You're gonna love this stuff. So do that, which is completely separate from this class. But we as a federal organization, we do what we do based on this risk management framework. So just a couple of documents to kind of get you sort of into conceptualizing what it is I'm talking about. It's not on the test. It's on the CAP exam. If you the companion exam to this one for your 9% SIP bonus would be the CAP exam, the Certified Authentication Professional. And it's by the same people that run the CISSP. But all this CAP thing, it's all about RMF. It's all about the risk management framework. So again, I'm telling you from my bottom of my heart, just go read 800-37. It's short, sweet, to the point, and it's kind of the guiding documentation for all the other stuff that goes on. So it's worth the read to kind of pull you into that environment a little bit, just so you have a working knowledge of what people are talking about. And it's directly related to what we're talking about literally right here. So enough of that. Okay. And of course, what good is all this unless you have policies to back it up, written policies that then can be implemented using our various tools and so on. So again, there are guidelines. These are, as you can look at these guidelines and go, these are pretty loose. Not a lot of specifics here. And no, there aren't. But you got to start with the guidelines before you can, go into specifics there. So something to think about. And if I had to guess, I'd say that there's activity 3-1 about managing data security here. And this one, has you, well, it's a more or less a discussion item. It's talks about BitLocker and so on, and asks you a couple questions. So it's again, it's useful. But now we're into application security, and I think what we're going to do is once I get, hang on, let me check something out here. Let me get through topic A, then I think we're going to go ahead and break for lunch and then come back. You'll find that there's exercises in the logical labs. Oh, by the way, not that I can see your hands right now. I assume everybody was successful at getting into the logical labs from the Logical Operations website. I'm further assuming that you all did the labs from Lesson 1. And now the labs for Lesson 3 are relevant, so you're going to be wanting to do those today as well. Okay, so activity 3-1, basically it's essentially a BitLocker exercise, which is useful because someday we're going to be able to use BitLocker and the companion BitLocker 2 Go for securing portable devices. That some portion of that is going to be available to us or relevant to us at the State Department, and that exercise is actually a live exercise that involves digging into the server and going places and doing stuff. Okay, let me move past that into application security. So we'll get through here, and then we'll go grab some chow. All right, let's talk about application security, right? It's all about following proper procedures during the development of the application. Once the application has been deployed, there's little you can do to secure the internals of that application. Once it's left the building, it's out there now. So it's really the main thrust of this is proper procedures during the development phase. Proper development. Proper development is kind of largely like the 90% of this thing. And then once it's deployed and maintained and so on, that obviously needs to be handled properly. But it's all about developers. Getting developers to understand security, that's difficult. You're right. There's no question about that. Not everybody develops applications with the proper level of security in mind. However, to their credit, firms like Microsoft and so on have developed developer tools. Visual Studio comes to mind, the Microsoft development environment, that supports and enforces a variety of security measures during the development process. So the tools we use have gotten a lot better, a lot smarter. And contrary to popular belief, developers can be trained. They can be. I used to develop. I did some Visual Basic work myself in the past, so I've written programs and stuff. But I didn't start really doing that until after I'd already had some security background, so I kind of understood the process. But the point is, it's the large majority of this is kind of out of your hands. I mean, once the application is deployed, you have to, you only have access to obviously a certain portion of that application. You don't have necessarily application or access deep into the guts of the application, the actual code in there. So again, let me move on from there. So application security. Patch management. Now the concept is, once an application is deployed, it's very seldom static. It's often updated, version number increases and so on. So there's a process in place to ensure that all of your good work isn't undone by sloppy patch management. Here's an example of what we talked about before. Randy from yesterday, remember, he's in charge of some. This is hypothetical, by the way. Is in charge of some critical application, and this critical application is one of those things where downtime is bad. Okay, fine. Randy discovers there's a patch for the server that this critical application is running on. And just before he goes to apply the patch, he remembers, there's actually some procedures I should look up first. Let me look up in my patch management. Oh, it says here, for mission critical systems, I need to evaluate the patch on a non-production system. And this non-production system can be virtual. You can build virtual machines within Hyper-V or VMware or whatever virtual environment you're working in, which in most cases satisfies any requirement for testing, because virtual machines are just as real machines, just like the Matrix, But anyway, once it gets through the non-production system without causing a problem, only then are you allowed then to implement it in the production systems. So you want to catch those, because again, these patches come from who? Developers. And developers, are carbon-based life forms primarily, and the things they develop are flawed. And not every flaw is immediately obvious. Sometimes it manifests itself as an incompatibility with a very specific hardware configuration. You can't necessarily test every possible hardware configuration, hardware-software combination, and there might be some glitch that is developed that you didn't foresee or you weren't able to test. And that's where this testing comes in, to where those production systems need to be protected by allowing you to test on a non-production system, which would very potentially reveal that incompatibility or that problem. Okay, so again, first of all, develop some patch management guidelines, and then once you've developed patch management guidelines, follow the patch management guidelines. Okay, for non-critical systems, really kind of who cares? You're probably wasting time testing that stuff on a non-production system, because if your production system goes down, what's the likelihood? There's like a 2% chance my production system will go down. For a non-critical system, that's pretty good odds. For a critical system, I'm not taking those odds, because if it was me, I would be part of the 2%, and then I'd get fired, and that would be bad. All right. Let's see. System for patch management. If you look in the book, the steps are basically several times. There's a reference of review. You review the patches, determine which patches apply to you potentially. Review and triage the updates. Basically, some updates are critical. It's like, you must apply this before close of business today, or your business is going to go out of business. And there's other things that are important but not critical. And then there's other things that are, language updates and, stuff that's maybe not critical. So you got to assess that. Somebody in your organization has to be given the responsibility to assess the potentially hundreds of daily patches that are made available from the vendors, and prioritize them. So that's a job for somebody in your organization. Create an offline, non-production testing environment, which can consist of actual real live hardware, which is probably preferable, or it can be a virtual setup that can be built up and torn down as necessary. And then have some delivery schedule, develop a delivery schedule, like they suggest, immediate push delivery of urgent patches, to where you push those out via some group policy mechanism. Or you've got a weekly push of improved important updates that are not maybe as critical, and then maybe create a location where users can pull the non-critical updates as necessary. So again, there's kind of a step-by-step process there. Not, the process isn't, I wouldn't say, specifically testable, but it's kind of a logical, common sense setup you got going there. Some security methods. The term configuration baseline. You have your base system, your initial installation. You take the measurements, you take the performance measurements and the data measurements, and that becomes your baseline, a baseline for comparison. As you apply updates and do things, you compare the current measurements with the baseline to see where any potential problems might occur, any potential performance bottlenecks or other issues. Application hardening. Hardening is removing vulnerabilities. That, and honestly, application hardening, most of that takes place during the development cycle. Because once it's deployed, there's it is what it is. Now there's things you can enable and disable and so on. But a lot of that happens during the development process, which generally you're not a part of. And then, of course, once the application is deployed, then you follow your patch management techniques to make sure your application remains safe and secure and happy and so on. Okay, remember buffer overflow. Remember buffer overflows. This is what I'm talking about. This is the code that's not fun and sexy to write. I mean, writing the code for the program to work, that's fun. But writing the maintenance code, the input validation code, that's sometimes that gets pushed off so I can meet my release date. We'll develop that we'll push that out as an update later. We just need to get this code out there right now. But input validation is where, let's say, using this slide as an example, I've got an application that has a date field in it, and my date field is looking for 2 numbers, a slash character, 2 more numbers, another slash character, and then 4 numbers. And you can even configure those numbers to fall within a certain range. You can configure whatever. Point is, that's the expected format of this piece of data. So the bad guy who's testing, looking for these vulnerabilities, he's going to put in the data. Then he's going to add additional overflow data. See that delete table users? You don't need to know much about databases to know that delete table users is probably bad. So the concept being, our hero programmer has written the input validation code that's going to check the input the user provided and go, sorry, that input does not meet the criteria, please try again. So that malicious user is going to go, curses, foiled again. I have to find some other avenue to exploit. So again, a lot of Microsoft updates on like Update Tuesday, a lot of the critical updates, they're buffer overflow fixes, guys. That's what they are. I mean, a lot of them are responses to buffer overflow conditions the bad guys discovered. And this is the response is the input validation code to lock down those buffer overflows. And of course, you're going to argue that shouldn't those idiot programmers have done that before they released the program? The answer is yes, but there's plenty of forces, market forces, that many times prevent that from happening. Because if you're a major player like Microsoft, you're not going to miss release day. No, no, no. You're going to send it out there, and then your adoring fans out here in Radioland, we are going to use your program. We're going to find all the bugs and all the annoyances, and we're going to discover all these problems. We're going to report them back to you, and you're going to issue patches and updates and eventually a service pack. And then maybe, a year later, that program is what it should have been on release day. But that's the way, we've trained them to teach us this way, so it's our fault. But that's the way it is. That's life in the big city. What are you going to do? So, but again, input validation is the way to counteract / eliminate buffer overflow conditions. If you're not allowed to overflow the buffer, that problem goes away. The injection problem goes away. This is an example of a SQL injection attack. We're trying to inject some SQL code by exploiting a buffer overflow condition to get my code into potentially a buffer where that code is actually allowed to execute. And like I said before, that's bad. Input validation is good. Now, the thing about input validation is it's necessary for any kind of software, operating system software, application software, protocol software, whatever. And websites and applications are popular targets because, websites and applications pretty much is everything users interact with, so it's kind of a stupid, assertion there. But again, that's important in that the things that, the high value targets, for example, is there anything special about Internet Explorer? Not really, but it's well known that Internet Explorer was the target of many, 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 attacks. Because why? It was in wide use. It's that high value target in that, hey, this is what everybody uses to access the internet, so we're going to spend an unfortunate amount of time trying to find all of its weaknesses so we can exploit the largest number of users with the least amount of effort, kind of a thing. So obviously the popular applications, popular websites, those kind of things, those are going to be your high value targets, because it gets the maximum bang for the buck. And of course, requires careful coding. That means the developer has to do a stinking job and actually write the input validation code in the first place. So it's not careful coding. The user just has to kind of code it correctly and actually include the input validation code. Sounds easy, but it's time consuming, Now, speaking of validating, code can be, validated in multiple places. Now, the client side and server side. Notice it says to make it more user friendly, to enhance the user experience, validate on the client side. Catch all the errors on the client side before it's even allowed to be sent to the server. Your user's filling out a web form and they hit the submit button, but then they say, I'm sorry, this field needs to be filled out. This field can't be left blank, and this field contains invalid. Please fix that and resubmit. Oh, okay. And then at least, client-side validation allows you to ensure there's no obvious errors so that you're not wasting the server's time. The worst thing we can do is waste the server's time. Why bother sending unvalidated code to the server, only have the server go, I can't process this crap, and then just kick it back to you. So client-side validation, you perform the input validation. In many cases, you can do it in line. As a user tabs away from a form, from a field on the form, that can trigger the validation code, which can kick the user right back into that field with the little error message saying, hey, you need to do this. Oh, okay. Or all the validation code can be wrapped up in like the submit button. So the user hits the submit button, and then all the fields are validated, and the user gets multiple, like messages in red telling them to fix their problems. JavaScript, Ajax, I can't remember what Ajax stands for. Visual Basic Script, HTML5. There's, those are programs, applications, scripting languages that all run on the browser, and understanding how those guys work is useful for providing the client-side validation components. Now, see, this sort of is misleading. This kind of gives you the idea that you should do one or the other. That's not true. You should do both. You should do client-side and server-side. Just because it passes the client doesn't necessarily mean that data is kind of on the up and up, and maybe I'm trying to do something hinky that I want my server to catch. But input validation at the server is going to look over that data too, and if it's in error, it's going to kick it back. And there's a variety of other languages, Perl and PHP and so on, active server pages, other things that are running on the server that perform this validation. So really, even the book says it's recommended you kind of employ a combination of techniques, client side and server side. If you do it right, it's not really going to enhance. It's not really going to affect performance, because if you can catch errors on the client side before you even bother the server with your input, that's good. At least the server is going to be able to process it. And then, of course, the server then is going to have the final sanitization step there to make sure that code's works right. Okay, whoops. He said error and exception handling. So programs are designed to do what they do, but if there's an error, like for example a division by zero error, you can't divide by zero, that's bad. That should trigger a call to an error handling routine. And a lot of you've all experienced errors. You do something wrong, or your application does something wrong, and you get an error message that pops up and gives you some information about the error. What you want to do, well, more specifically, what you don't want to do, you don't want to tell the bad guy valuable information that you don't need to. For example, let's assume that this guy was trying to learn some information about your username and or password. So the guy, puts in a username, puts in a password, and if the error message comes back and says invalid username, it's like, okay, now I know I've got an invalid username. Or if it comes back and tells you invalid password, it's like, aha, I've got a good username, but I've got a bad password. What you'll find is, if it's properly written, you'll get some generic message that says, username / password combination not recognized, or something like that. In other words, it doesn't tell you, do I have a good username? Because that in itself is valuable intel to the bad guy. Now, of course, we're not doing ourselves any favors. Generally, it's not too hard to figure out your username at the State Department. It's your last name and your initials, unless there's more than one of you in the gal, in which case then they start throwing some numbers in there. But for the large majority of state employees, if I know your name, I've got a pretty good shot at knowing your username as well. And then it's all about the password. So whatever, it is what it is. But you want your error, your exception handling to well, first of all, you don't want a situation where a user gets stuck and there's no way out of an error condition. I've seen badly written programs that you get stuck in there. You have to reboot your machine to get out of it, kind of a thing. But you always want the user to hit cancel or escape or something to be able to take them all the way out and not be stuck in some error handling loop of doom, kind of a thing. Okay, that's exciting. Stand by. How are we doing? Okay, we're right on track, believe it or not. Earlier, we mentioned the concept of a reflected denial of service attack. A cross-site scripting is an example of that. And a cross-site scripting attack basically takes two forms. In one form, the stored attack, this is where the bad guy goes to the web server, a poorly secured web server, by the way, that allows them to enter executable script code into like a comment field or a notes field or something. So the user goes and lays that malicious script in this comment field. The target user comes along, goes to the website, reads the comment, causing that executable script to execute. Now his machine is infected with your script, and it's all because the web server was poorly secured and participated in the attack. That's a stored attack. Now a reflected attack takes a different form. You've got the URL, the actual address itself. You can put some form of attack code actually in the address itself, and basically spoof the source address, send the malformed URL to the web server. The web server recognizes it can't process it, redirects it back to you. When it's back to you, it's back to whatever source address you put in there, and it hits the source, and that the code in the URL is attack code, which then gets deposited on the target machine's machine. You couldn't put it on there directly, but for some stupid reason that guy trusts the web server, so when the web server inadvertently redirects this attack code to your target, that's what a reflected attack is. So again, cross-site scripting, there's plenty of ways now to minimize the damage of cross-site scripting. Properly configuring your web servers to recognize, identify, and not participate is the main one there. But that's what XSS is. Those of you that are OCD and don't like the fact that X is used to represent the term cross, that's because CSS stands for Cascading Style Sheet, which has to do with HTML coding, and it's kind of already a well-known predefined three-letter identifier. So they chose to use XSS instead. So that stands for cross-site scripting. Just thought I'd throw in a little historical perspective for you. Cross-site request forgery, taking advantage of a trust relationship between the website user and the website itself. So we're going to take advantage of. So in other words, you do it all the time. You go to a website and you have that website remember your credentials, and there might even be a little block that says "Remember Me" or something like that. So you do that, and every time you go to that website, your credentials are automatically sent there, and you're automatically logged in. You don't have to log like Facebook. You probably have it set to have Facebook automatically recognize you, so you don't have to enter your credentials again. Well, if somebody else gains access to your machine where you've got those automatic trust relationships set up, well, then bad guy can then access Facebook or access whatever website it is with your pre-established trusted connection, and boom, he's in. So it's kind of hard to get users to not use that. Don't use that "Remember Me" option. It's dangerous. Unless truly you're the only user of a particular machine, you really shouldn't do that kind of stuff. All right. So again, cross-site scripting methods to prevent it. Don't allow HTML formatting in form fields. So HTML code, right? I mean, you've got like the greater than and less than symbols for enclosing tags, and the slash character. I mean, there's a lot of just kind of harmless everyday symbols that are part of HTML code. But what you can do is you can restrict HTML formatting, meaning if you put a greater than symbol or a less than symbol in this form field, this note field, you can have it put in what's called the escaped version of that, which is not recognized as script code. It's just recognized as just a plain generic character. So again, even though it looks like it looks like script code, the website's not going to interpret it as script code, because actual scripting HTML formatting is not allowed. So these escape characters that preserve the look and the look and feel, but without the executable nature of it. So that's good. dir, input validation, that's good. Minimize the kind of information that's stored in cookies. You really don't want to store in a cookie anything even remotely confidential, because if those things get snagged off the line, it's just text files that can be opened up and revealed. So you want to minimize the sort of information that's available there. I mean, it might be information that makes sense to the web server, but wouldn't make sense to anybody else. Encrypt stuff. Don't use that remember me thing. There's a reference in the text to a testing methodology called fuzzing. One thing about developing an application is part of the development process is the testing process, where you have to test and make sure that your thing works and it doesn't blow up if you put in something wrong, So fuzzers, these fuzzing applications, they send to this application you're testing all sorts of out of bounds, wrong, poorly formatted information to test to make sure that nothing bogus gets through and causes the program to glitch and act stupid. So it's these fuzzers are real good at sending a high volume of really wrong information that you might not have thought of on your own, or you don't have the time to do. So the concept is you want to break the program. If you're going to break the program, this is the time to do it during your testing phase. And these fuzzing tools are ways to help you identify weaknesses and vulnerabilities that you missed, or you didn't see, or you didn't think of, or you haven't properly tested for. So there's that. So fuzzing's a real thing. They reference a couple of fuzzing tools in the Peach Fuzzer. Pretty funny, right? Something called Spike Proxy. All right. Web browsers. You got your Internet Explorers and your Firefoxes and your Operas and your Chromes. They're more alike than they are different. They all do mostly the same stuff. There's a couple of enhancements from one machine to the other. Some of them are faster, some of them are slower, but they're more similar than they're different. So for each web browser, what I would do if I was you is, before I went to take a test, I would go to probably Opera, not Oprah. I would go to Internet Explorer, go up there, select Internet Options, and go through the tabs and kind of familiarize myself with where these various things are. There was, remember adware? Back in the early days of adware, you'd get these pop-ups. And sometimes the pop-ups came so fast and furious you couldn't even make them go away in a timely enough fashion to even work on your application, right? So there were third-party pop-up blockers that appeared that let you block these pop-ups. And then very shortly, all of those guys were put out of business. Actually, probably a lot of those guys were purchased by Microsoft and whoever, and their technology was then incorporated into the browser. So now all your browsers have pop-up blockers that you can manage. You can control what sites you allow pop-ups, what sites you don't allow pop-ups. I would do that. I would go and learn where that is. Parental block, a lot of these, it's based on the fact that these websites like voluntarily encode their pages to interact with these parental controls. So if you've got a web page that's designated as an adult page, and you've got parental controls saying don't display this page, well, then that page won't display to the youngins, But again, the problem with that is it relies on sort of voluntary compliance by the web servers, the operators themselves, and that doesn't really happen. So it's really kind of but parental controls allow you to control things like usage, and you can restrict them to go to specific sites and so on. So go there, learn how that works. Automatic updating, it's probably generally a good thing to have this thing, have settings to automatically update as necessary, because a lot of those automatic updates are just to provide security fixes, because your web browsers are probably the #1 application that's targeted by hackers and bad guys. So there's going to be statistically more updates issued against web browsers than most other types of software. Encryption, you need to determine how to support encryption, how to support SSL and TLS, and so on. Does this saying use a web proxy? Your web browser needs to know how to contact the web proxy, and you'll find that typically on like the connections tab. And there's a checkbox: are you using a proxy server? Yes. What's the address of the proxy server? What's the port number you use to talk to the proxy server? So you need to determine the level of proxy support. Web content. What they want me to tell you about that. Basically, what they're going for is, these web browsers are pretty cool. They're pretty neat. They do lots of fun things. And most of those fun things revolve around scripting, like VB script or JavaScript. JavaScript is kind of the industry standard. But a lot of bad things happen as a direct result of scripting. So really, kind of the only way in some cases to prevent bad things from happening is to actually disable scripting altogether. And you're going, but that makes my life worth living, and it's more fun, and I have a better browsing experience if I can interact with my web pages using script code. Well, certain web pages you absolutely don't want to use script code on. Now, of course, you can configure your browsers to allow scripting on some pages and not allow it on other pages, but that's something to look at. And then there's going to be a security tab with all sorts of individual, dozens of individual security settings. So the point I'm making is, pick probably use Internet Explorer as your baseline, and go to the Internet Options page for your browser and go through and see what's behind all the tabs and see where the options are, just so you know where stuff is. And then you probably want to go to Chrome or Firefox or whatever other browser you use, and go to, in Chrome, it's options, and you'll find all that same stuff there. It's listed differently, and it's not in the same, obviously, presentation, but it's all still there. You just want to learn how your particular browser platform handles all of these security related issues. So that's definitely something I would use. Again, on the test, I would use IE as my baseline for kind of understanding where these things are and how they interact with each other. Come on now. Establishing web browser security. The host machine, the machine on which the web browser is running, you want to perform the hardening techniques on that. You want to harden the operating system, harden the physical machine itself. Keep your software up to date. How many times has somebody come up to you and says, Internet Explorer is acting weird, it's doing this, and then you say, have you installed the latest version? Go ahead and do the update, and then if you're still having the problem, come back. 9 times out of 10, that'll solve the problem. Having the updated version will solve the problem. We might not have the ability to install whatever versions we want on our State Department machines, but you get the idea. There are security settings. Configure them. Like I say, sometimes disabling scripting is really the only way to prevent malicious code from getting into your system. Because you may have a job where your job is to navigate to these sketchy websites because you have to monitor what they're up to and whatever. And sometimes that's you get security news from these sort of dark, evil places, and so again, you don't want code automatically running on your machine if you can avoid it, that sort of thing. Disable autocomplete and password saving, and that's especially true. How about this? It's primarily true on a machine that you share with somebody else. If you're the only user of a machine, arguably you could leave those settings be because nobody else is going to, inadvertently, stumble across something that was saved for you. But again, just from a strict security perspective, those things are bad. Autosave and autocomplete. And of course, you need your antivirus software, your anti-spyware software, your anti-adware software, those kind of things. In Windows 7, which I believe, well, most of you are probably using still. Windows 7, you've got two products that are built in. You've got Defender, which is your anti-spyware, anti-adware program, and you've got Microsoft Security Essentials, which is your antivirus. And of course, there's third-party tools as well. Windows 8, might just be 8.1 and newer, I don't know. It's Windows 8 combines both of those into Defender. There's no Security Essentials anymore. That functionality has been taken over by Windows Defender. NoSQL, what's that? Oh, first of all, there's an activity for configuring a web browser that involves you actually, going into a web browser and configuring it. So you may actually want to do that. Not right now, but at some point. The instructions are pretty explicit. Okay, let me scroll past all this. Fascinating. That's a lot of stuff. So yeah, just following the exercise will kind of walk you through everything I told you about already. Okay, NoSQL databases, or NoSQL. So the concept here, so again, there's many different database models. There's something called a relational database, which you have a series of related tables where your information is stored, and the query involves retrieving data from these multiple tables and returning your result set. So that's kind of a structured query language concept, this whole relational database thing. Now, a NoSQL database, you're organizing data a different way. I mean, a lot of us are very familiar, very comfortable with relational databases, but newer technologies basically are pointing us at alternative ways of storing and retrieving data. So these so-called NoSQL databases, where we organize our data in different ways. Key value stores, document stores, graph stores, column stores, and again, there's different types of information that would not necessarily have gone together before. So again, this is something you'll see in things like big data projects, because it's traditional relational concepts. Those tables would be too big to be useful. So you need another way to store and organize that data. So this NoSQL database enables us to kind of embrace these sort of newer paradigms, like the big data sort of paradigm. So database security, I mean, let's see, relational databases, you've got different roles, role-based security. You've got an administrator, which can do plenty of stuff, and then you've got users, which can only do maybe a subset. Like, for example, I've got a database that contains a lot of sensitive information, but you need access to some of that data in the database, but not any of the sensitive stuff. So I can create what's called a view, and that view exposes maybe 3 columns of data out of my 50-column database, and just gives you just the stuff you need without me having to maintain multiple databases. I can use one database and provide different views of that data to different users based on their clearance levels and their needs and so on. But they support encryption and access control and permissions. It's if you're a network admin, sort of a administrative user of some sort, you're very comfortable with encryption and access control techniques and permissions and so on. The NoSQL databases, being as how the data is so much different, may not support the normal authentication techniques and methods or normal authorization procedures and so on. So it's going to be a different way to manage and handle that sort of data. Just something to be aware of. That takes us to both the end of, no, it doesn't take, it takes the end of topic B. So here's what we'll do. It's currently, I don't know, 11:30, 10:30, 12:30, somewhere around there. So let's come back at whatever 15. Let's come back at 15 after the hour. No, 15 after the hour. No, let's come back at 30 after the hour. So let's go to lunch for 50 minutes or whatever. We'll come back at 12:30 or 1:30 or 11:30, whatever time it is where you are. And you are just a virtual compendium of information, Clay. I appreciate it. All right. So anyway, I will see you guys on the back side of this thing. I'm going to go capture this recording, so let me stop it, and I'll talk to you then.